Recently, the Earth has been beset by many problems such as global warming, infectious diseases, and natural disasters. To resolve such global issues, SATREPS works internationally to obtain new knowledge that can advance science and technology.
SATREPS is a new program with developing nations, bringing value to the global community. We engage in research partnership with research institutions in developing nations, tapping into natural resources, natural data, and human resources into play of innovation. We call this inclusive innovation. We conduct 60 projects all around the world. One of the projects is called Climate Prediction using Earth Simulator in South Africa.
This project to predict climate variations is led by Professor Toshio Yamagata in the Graduate School of Science at the University of Tokyo. Professor Yamagata is also head of JAMSTEC's Application Laboratory.
Based on an agreement between Japan and the Republic of South Africa, we started a new type of bilateral application project last year for sustainability development in South Africa. The title of our project is Prediction of Climate Variations and its application in the Southern African region. This project is to contribute to enhancing capacity for seasonal climate prediction in South Africa. It is funded by JST and JICA in Japan and DST in South Africa. Major institutions involved in this program are Application Laboratory of JAMSTEC, School of Science of the University of Tokyo, and Applied Center for Climate and Earth Systems Science of CSIR in South Africa.
The climate in southern Africa varies widely, from dry to subtropical. Here, production systems depend strongly on nature, making them extremely vulnerable to the risk of climate variations. In recent years, it's been confirmed that climate variations phenomena are also occurring in the South Indian and South Atlantic Oceans. These include subtropical dipole mode events, which are similar to El Niño and La Niña. To find out how such long-term variations happen, researchers need detailed field data and the Earth simulator, which uses a supercomputer to analyze and predict variations.
Agriculture and industries in South Africa are vulnerable to abnormal weather events. Therefore, to reduce risks of those events, it is important to realize a sustainable society in this particular region. This is the goal of our bilateral project. We climate scientists now know that those abnormal weather events are mostly due to climate variations under the global warming stress. So, in order to achieve our goal, it is very important to enhance regional capacity for seasonal climate prediction. Our Japanese team consisted of Application Laboratory of JAMSTEC and School of Science of the University of Tokyo has achieved world-leading scientific results such as discoveries of the Indian Ocean dipole and the high prediction skills in seasonal climate forecast using the state-of-the-art ocean-atmosphere couple model called SINTEX-F. We decided to apply our scientific knowledge to this particular region of Southern Africa for the societal benefit of people suffering from devastating natural disasters.
Detailed prediction data obtained using the Earth simulator makes it possible to investigate various effects of climate variations.
Seasonal prediction data simulated by the Earth simulator can be used for understanding mechanisms of global climate variations under the global warming pressure. It is also used for enhancing infrastructure in developing countries for disaster prevention, such as for adjustment water levels in dams before torrential downpours. Moreover, seasonal prediction data from the Earth simulator can be used for preventing infectious diseases carried by vectors like mosquitoes. climate variations have huge impacts not only on consumer sectors as textile, beverages, trade and tourism, but also on product sectors, basic industries of each country as commodity market and energy consumption. Ocean current forecast data can contribute to efficient fisheries, improvement of oil consumption of merchant vessels, maritime safety and marine security. Global prediction data from the Earth simulator have such various applications and thus contribute to well-being of industries, economies, and societies in the world.
Predictions from the Earth simulator are expected to be useful in many fields. Professor Yamagata would also like to use this type of data to provide information services worldwide.